Let's go through some examples of latency and throughput in computing systems. So the first example here is something we should all be familiar with, that's spell checking a document. And now here's a question. Which one of these is better? A system that can do 10,000 words checked in 10 seconds, or a system that can check 10 words in 0.1 seconds? Well, let's take a look at it from 2 points of view. Say you care about latency. So you click the Start button to spell check. How long does it take until you start getting results? Well, with the first one here, 10 seconds later, you're going to get all the misspelled words in your 10,000 word document. But for the second one, after a tenth of a second, you're going to get the first misspelled words because you'll be able to go through and check 10 words. So for this one here, from a latency point of view, this one's going to take a long time to find all the errors. This one's going to find you your first error pretty quickly because it can get through words faster. Sorry, it can get to the first words that are wrong faster, whereas this one's going to do them all in bulk. Let's take a look at it from a throughput point of view. So the first one over here does 1,000 words per second. The second one does 100 words per second. So if I'm doing this in a bulk or a throughput mode, this is 10 times faster. But if I'm doing it here in a latency mode where I care about how quickly I get my first result, this one can be potentially 100 times faster because it returns results much more quickly. So which one is better? Well, it depends on what you're trying to do. If you're using Word and you're clicking on it, you probably want this one because it'll get you the first misspelling faster. If you're processing a big document in bulk and you just want a list of the mistakes, this one's probably faster because it's got 10 times higher throughput. Let's take a look at another example. This is echo cancellation. So echo cancellation is something you've all experienced if you're using Skype. It's when it tries to get rid of the echoes on the other end if people aren't wearing headphones. So which one of these is better? A system that can process 1,000 milliseconds of audio in 100 milliseconds, or a system that can process 10 milliseconds of audio in 5 milliseconds, or if you need more information. Well, you've probably figured out now that needing more information is usually the right answer to these questions, and it turns out that it depends on whether you're focusing on latency or throughput. So let's say you're looking at latency. So if you have this latency point of view, you get one of these, it takes 100 milliseconds before you get your first bit of audio processed. So you did 1,000 milliseconds of audio, it took us 100 milliseconds to process. In the second one here, I get my first results back in 5 milliseconds. So if I'm concerned about latency, this one's 20 times lower latency to get a result. But if I care about throughput, the first one is 10 times faster than real time, the other one's 2 times faster. So for throughput, this one's much faster than that one. Now, where would you care about latency versus throughput in audio processing? Well, it depends on what you're doing. So if you're doing real-time chat on Skype, what you care about is latency. If it takes 100 milliseconds to look and see if there were any echoes in the last 1 second of audio, well, you're not going to get a lot of echoes. In fact, you won't get any echoes that are less than 100 milliseconds. You want the one that's going to have the lowest latency for processing the echoes here. On the other hand, say you were editing a film. You wanted to go through all the audio in a film and remove echoes. Well, this one is going to go 10 times faster than real time, whereas this one's only 2 times faster. So in this case, where you don't care about the latency of individual results, you care about the bulk processing, the one that has the higher throughput is better. In the case over here where you're doing a real-time interaction where you care about latency, then it's going to be the one that's latency limited that's really the important one. So again, whether you care about latency or throughput depends on what you're doing. All right, so what do we have here? Latency or throughput depends on what you're doing. If you're doing bulk processing, so lots of pixels, the recorded audio, that sort of thing, you're processing an image. You don't care about individual pixels in the image, but the whole thing, then you're throughput focused. If you're dealing with individual actions, so a user clicking on something or processing audio you're listening to, it's a latency focused thing. And now we get to the question of why should you care? And I alluded to this in the introduction, that things are changing depending on what you're doing here. And the change is as follows. Up until about 8 years ago, all processors were latency latency focused. So what they cared about for performance was how fast they could calculate things. Recently, processors have started becoming throughput focused. That is, now when you talk about performance in a processor, talking about the time to get results on average, bulk results. And we've seen this. This historically making processors latency focused, this is all about more megahertz, running CPUs faster, and that hasn't gone up very much. What has changed is we now get more parallelism. So you'll see we now have more processor cores all over the place, and processor cores help you with throughput, but not with latency. And so there's this change that's going on in how computers are built. And why should you care about this? Well, if you want to make your code run fast. If you want to say, I'm going to write a program that runs faster on future processors, you need to understand the difference because future processors are becoming more and more throughput focused and having less and less advances in latency performance. That means you need to think about this when you're designing your programs and figuring out how they'll run in the future.